Hello, geometry students. Welcome to lesson 12 through on permutations and combinations. Right? So this lesson is only slightly difficult because you have to determine whether your situation is a permutation or a combination. So the idea behind a permutation is that the order matters, right? So that's an important idea. Permutations mean that order matters. So it matters in a group of, say, 5 people. Who's the first person, who's the second person. In a combination, order doesn't matter. I just need a group of 5 people. I don't care what order they're in, just bring them here. All right. So again, when you look at these problems today, ask yourself, does the order matter? Right? That's the definitive differentiating point. All right. So let's take a look at what's called the fundamental counting principle. So it says Manuel wants to advertise the number of one-topping pizzas he offers to his customers. How many different one-topping pizzas are available at Manuel's Pizzeria? So we are going to show this fundamental counting principle, which I think you guys know, using a tree diagram. Okay, so tree diagrams are very powerful. I think I showed one of them when I discussed your lesson 12.2 on conditional probability. Some problems using a tree diagram is helpful. So you use a tree diagram when you have different choices, right? So I want to build a pizza, right? So first off, there's size. So actually, there's 3 choices, right? There's size, there's crust, and there's the topping. So your first choice is the size. So what we do here is we start with like a dot right there, and we have 2 sizes. So I'm actually going to kind of go big with this branch, right? Okay, and we have a large and we have a medium. So we have a large pizza and a medium pizza, right? And this is again is the size choice, right? Okay, so you have your size. And then from there, you can choose 2 types of crust. You can choose deep dish or thin. So again, I'm going to try to go like big with these branches. So there, and I'll go there and down here, right? So now we have, for each choice, you can choose deep dish or thin, deep dish or thin. And again, this is your crust choice. And then after the crust, you have your toppings, and there are 3 toppings to choose from. So from each of these, I need to draw 3 and 3. That's why it's important to spread these out in 3 and then 3. All right? And it says sausage, pepperoni, cheese. 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 Right? And this is the fundamental accounting principle where we have size, crust, and topping to choose from, right? So if you look here, how many different ways are there to make a pizza? Well, it's just going to be the number of last branches. So if we just count these, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different pizzas. 12 different one-topping pizzas. 12 different pizzas. Now, a simple way to look at this is using what's called the fundamental counting principle. Right? This is typically, you might have done problems in the past where like you're trying to pick an outfit, right? You have so many pairs of pants, so many shirts, so many hats maybe, right? So down here, if you have, if you have m ways, let me scoot this up. If you have m ways for the first selection, n ways for the second selection, and p ways for the third selection, then to find the total number of selections, you just multiply all the possibilities. M times n times p. So in this situation, you had 2 sizes, you had 2 types of crust, and you had 3 toppings. So 2 times 2 times 3 is 4 times 3, which is 12. So it works. So this is the fundamental counting principle. Very important idea. Perfect. All right, next here. Okay, example 2. Find the number of permutations. Okay, so now we're going to talk about permutations. Here we go. Gabrielle is making a playlist with her 3 favorite songs. How many possible orders are there for her songs? Right, so first of all, right, we can actually take a look at all these 3 songs. So let's say she has 3 songs, A, B, and C. So the 3 songs will be A, B, and C. Now, the question said how many possible orders. So this means that order matters, right? Order matters. Therefore, it is a permutation. So when I look at this, I could do, okay, A, B, C. I could do A, C, B. That would be A being first. Now let's put B first. B, A, C, B, C, A. Okay, now I could do C first. C, A, B, C, B, A. And look, there are 6 possible ways to order those 3 songs. Okay. Now the other way to do this is by using part of the fundamental counting principle and factorials. So a factorial is defined as the product of all the numbers that are that integer all the way to 1, so down to 1, right? So all positive integers less than or equal to n. It is represented by n factorial, and here we go, right? So it's n times n minus 1 times n minus 2 all the way down to 1. Okay? So here, right, we have 3 songs, and we want to, put them in orders of 3. So we just do 3 factorial, which would be 3 choices for the first spot times 2 for the last spot times 1 for the third spot, because there's 1 song left, and 3 times 2 is 6 times 1 is 6. And there you go. So we can use factorials to do permutations as well. Right? And this is when the number of choices, right, match the number of spots. So we had 3 songs for 3 spots. All right, next. Okay, part B. Now it says Gabrielle wants to make another playlist with 5 of her favorite artists' 8 most popular songs. How many different playlists are possible? So now we want 5 of her favorite 8. So now the number of spots don't match the number of songs, right? And now it should say this, but we're going to assume that songs can't repeat. No repeating. Right? That's, I like this song a lot, so let's play it twice. No. Okay. So how can we use the fundamental counting principle? Well, now, right, it's similar to the factorial, but now we only have 5 spots. So 1, 2, 3, 4, 5. And notice I put multiplication dot. So for that first spot, we have 8 choices. Now, once we choose that first song, now we only have 7 choices, and then we have 6 choices, and we have 5 choices, and we only have 4 choices left for that last song. So this is a way to use the fundamental counting principle, but again, we stop it short. We don't go all the way down to 3, 2, 1. And this would give us 6,000. So when you multiply that together, that's 6,020 different playlists. Now, there's a second way to do this using factorials, okay? So, and here's how we're going to think of this. So if we use factorials, right, there's 8 factorial, but then we want 5, so there's a 5 factorial. So how do we combine these into finding this same number, 6720? So let's talk about this, right? So if all 8 songs, then how many ways can A, B, C, D, E show up, right? So let's say we have all 8 songs, play for all 8 songs. How many ways for A, B, C, D, E to show up, right? That's what we want to know. How many ways for A, B, C, D, E? So again, if we have 8 songs, so again, we could do A, B, C, D, E, and then the last would be, F, G, H, right? So these 5 will be constant in that order, but these 3 don't matter, right? So now let's rearrange them, right? So A, B, C, D, E, again, constant, but now let's call this F, H, G. And then A, B, C, D, E, but then now make this G, F, H. And then do A, B, C, D, E, but then make this G, H, F. And again, A, B, C, D, E, but now we'll make this H, F, G, and A, B, C, D, E, but now we'll do H, G, F. So in all cases, A, B, C, D, E stay in the same order, but the last 3 numbers got written in a different order, right? So what this shows is that there are 6 ways to write the same choice. 6 is 3 factorial, and 3 factorial is 8 minus 5 factorial. We need to take all these out because all of these are exactly the same choice if we're choosing only 5 songs. So here's how you build the formula for a permutation. You're going to take your 8 factorial. So this is going to come up here. You're going to take your 8 factorial, right? But then you're going to divide it by your 8 minus 5 factorial, which is your 3 factorial. So you're going to do 8 factorial divided by 3 factorial. And here's why. Watch. So what is 8 factorial? So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But then when you subtract when you divide the 3 factorial, 3 times 2 times 1, notice what happens. The 3's cancel, the 2's cancel, the 1's cancel, and you are left with, boom, exactly what you had over there using the fundamental counting principle. And you get the exact same answer of 6,720 playlists. So all of that discussion right here, all of this was to explain where this formula comes from, and on the next slide will be your formal introduction to the permutation formula. So the permutation formula, where the order matters, specific order. If I'm trying to choose from n objects and I want r of them, this is my formula, right? I want r objects taken from a set of n objects. And again, another way to think about this is if you do your n factorial, n times n minus 1 times n minus 2 times ... and you just go for r spots, right? And that's again using more of the fundamental accounting principle. I will show this to you. I hate to. On your graphing calculator, there is a way. You can also do this in Desmos graphing calculator, right? So I will show you this. So let me get you to the Desmos graphing calculator. And when you come here, right, I believe you just type in NPR with a parenthesis. And I think you can type in the number of objects. There are 8 objects, and we want to pick 5 of them. And there you go, right? So in capital PR, 8, 5, and it does the problem for you. Again, I hate to show you this, but it's there, so why not? All right, good deal. So that is our permutation talk. The next video will talk about combinations.